Think about the most dangerous object you've ever handled. Maybe broken glass, maybe a live electrical wire. Now imagine that object isn't just sharp or dangerous, it's alive, invisible, and one mistake in handling it could trigger a serious public health emergency. That is the reality for the scientists and laboratory professionals who study Ebola. I'm a medical laboratory technologist, and in my profession, we routinely work with microorganisms safely in controlled clinical settings. But Ebola is in a different category altogether. We don't just store it in a separate room. In many cases, it's handled in entirely separate high containment facilities designed specifically for viruses like this. Governments regulate Ebola research because the margin for error is incredibly small. Ebola is classified as a risk group 4 pathogen, one of the highest risk categories in infectious disease research. So it can cause severe illness, has a high fatality rate in some outbreaks, and spreads through direct contact with infected bodily fluids. The goal of these regulations is not secrecy or exclusivity, it's containment. Every safety layer exists to make sure the virus never leaves the laboratory environment. So to understand where Ebola is studied, you first need to understand something called biosafety levels, or BSL. Think of them like layers of security. BLS 1 is the most basic level. These are usually teaching or research labs working with microorganisms that generally don't cause disease in healthy adults. Standard lab coats, gloves, and basic hygiene practices are usually enough. BSL 2 is more controlled. This is where labs may handle organisms linked to human disease, like certain bacteria, certain viruses, and access there becomes more restricted. Biological safety cabinets are often used and stricter protocols are in place. BSL 3, this is where things become much more serious. Here, scientists may work with organisms that can cause severe disease through inhalation, such as tuberculosis. Airflow is tightly controlled. Specialized respiratory protection is often required. The lab itself is engineered to prevent contaminated air from escaping. And then there's BSL 4. This is the highest level of biological containment in the world. And this is where viruses like Ebola are studied. A BSL 4 lab is essentially a lab within a lab. Scientists wear fully enclosed positive pressure suits connected to specialized air systems. Now, if the suit is damaged, air flows outward instead of inward to help protect the person inside. Workers go through extensive decontamination procedures every time they enter or leave that facility. So everything about those labs is designed with one goal: maximum containment. And here's the part most people don't realize. There's a major difference between testing a patient sample and actually growing live Ebola virus in a laboratory. Culturing the virus, meaning growing and multiplying it for research, carries extremely high risk and requires maximum containment conditions. Diagnostic testing is totally different, but it still requires extraordinary precautions. So if a patient is suspected of having Ebola, laboratories follow highly specialized handling procedures. And in many cases, molecular testing methods are designed to inactivate the virus early in the testing, even before further analysis takes place. Even trained laboratory professionals treat these specimens with extreme caution because infectious virus can remain present in bodily fluids and exposure risks must be minimized at every step. This is why not every hospital or routine laboratory can safely process suspected Ebola samples. Now here's a question nobody is asking. If Ebola requires some of the highest levels of containment in the world, why is there controversy over where Ebola patients should be treated? In my next video, we'll break down the debate surrounding a proposed Ebola facility in Kenya and why opinions are so divided.